Okay, this video will cover the second part of either Trig Notes 1.7 or PreCalc Notes 4.7. Remember, the topic here is dealing with inverse functions. So if I'm going to ask you to find the tangent of the sine inverse of negative 3/4, first thing that we want to do is we want to figure out which quadrant that this will exist in. So there's two questions we need to ask ourselves. First of all, in which two quadrants would the sine values be negative? Well, what I know about the sine is the y values, and the y values have to be negative down here, so that'd be 3 or 4. Which two quadrants can I take the sine inverse in? And those would be the first and fourth quadrants. So what that tells me is that this condition for this to exist would have to happen in the fourth quadrant. So let's go in the fourth quadrant, draw ourselves a reference triangle. There's my reference angle. And let's make that triangle have this characteristic, the sine equal to 3/4. And I specifically wrote it as 3/4 and not negative 3/4 because I'm not sure whether the 3 or the 4 is the negative. I'll find that out when I go and place it in on the triangle. So opposite side has to be 3, hypotenuse has to be 4. Now I know for sure that it is the 3 that is negative. And you may be asking yourself, well, why did you do that when clearly when I wrote it like this, this says negative 3 divided by a positive 4. Well, I could have wrote it like this, negative 3/4 like that, where it's not clear which one is the negative, either the numerator or the denominator. So just because the negative is with the 3 here doesn't mean that it will be here. Your hypotenuse will never be negative. It makes sense that the 3 is negative here because of the fact of that this y value is negative when I go down. So therefore, I know that my triangle has to look like this. Alright, so with that being said, the next thing I want to do is find the tangent now of this triangle. And now tangent is opposite over adjacent side. So opposite side I have, adjacent side I don't have. And so I'm going to use Pythagorean theorem to find that. And negative 3 squared plus b squared has to equal 4 squared. Subtract the 9. I would find that b would end up being the square root of 7. And again, what's important for me to understand is when I put that on there, don't just assume it's positive. Check to make sure, according to the quadrant it's in, that distance should be positive. That should be positive because the x values are positive in the fourth quadrant. Very well could have done this problem in the third quadrant and got that to be a square root of 7, but I would have had to recognize that over here, the triangle was over here, this would have to be negative square root of 7 there. Like I said, if my triangle looked like that, because this distance would in the third quadrant, the x values are negative. So make sure that you assign the correct sine value to it, either positive or negative. Algebraically, you'll get it to be positive, but you could have to make it be negative if it's in the quadrant that has a negative either x or y value to it. So ours was positive, so we'll leave it as the square root of 7, but I don't want to leave my answer like that. I want to rationalize. So I'll get rid of the square root of 7, and I'll end up with negative 3 square root of 7 over 7 as my answer. Okay, this next problem, I'm asking you to find the cosine of the arcsine of 2x. And you'll notice that I didn't actually write over here which quadrant it can be in, because when you're doing these problems, you're not going to have those blanks to fill in, so I want you to think about those things first. You want to figure out sine of 2x, that's a positive number, so you want to know where is the sine positive. And the other thing that you want to ask yourself is where does the sine inverse exist? So you have to think about the quadrants here. Sine is positive where the y values are positive, and that would be in the first and second quadrants. And the sine inverse exists in only quadrants 1 or 4. So here we've discovered that this has to be a first quadrant triangle. So let's go ahead and draw that triangle in the first quadrant. Get a little bit nicer. There's the angle we're going from. So now let's give this triangle a sine equal to 2x. Now in this case it's opposite over hypotenuse. So easiest way to make this be a fraction is to put it over 1. So opposite side, hypotenuse. Now we can go through and we can ask ourselves, what is the cosine of this triangle? Well, I know that the formula for cosine is adjacent over hypotenuse. Adjacent side I don't know, hypotenuse is going to be 1, so it's going to be over 1. So if I'm going to find the adjacent side, I'm going to use Pythagorean theorem. 2x squared, again put that all in parentheses, plus the adjacent side squared equals 1 squared. Now, a common mistake that students will make when they get to this point is they'll say, oh, this is the difference of two squares, so this has to be 1 minus 2x. Well, I can't take the square root of this binomial, because if this is the difference of two squares, when I factor this out, I get 1 minus 2x. And 1 plus 2x. So this is not a perfect square at all. So don't make the mistake where you try to take the square root of that and write it as 1 minus 2x, because that would not be correct. Even though each of these individually are perfect squares, together as a binomial, it is not. So I would just leave my answer as the square root of 1 minus 4x squared. Put that over here. And that would be then my final answer. If we're taking a look at the arc sine of the sine of 45 degrees, what we want to think about first of all is the sine of 45 degrees. Clearly we know that that's in the first quadrant. What two quadrants does the arc sine exist in? Quadrants 1 or 4. So as we think about this, what we're really asking ourselves is the sine of 45 degrees. If I go to my unit circle and I look at that, that is the square root of 2 over 2. And so now I'm looking for the sine inverse of the square root of 2 over 2. I just wrote it, changed it from arc sine to sine inverse. So I want to know which angles in either quadrants 1 or 4 have a sine of the square root of 2 over 2. Well, if I look in quadrants 1, I'll see that it's 45 degrees. If I look in quadrants 4, I see that all of the sine values are negative. So I know that it can't be in quadrant 4, and therefore my answer has to just be 45 degrees. The other question that comes up too is, as you're looking on your unit circle, you'll notice that 135 degrees has a sine value of square root of 2 over 2. So the question that usually comes up during this section is, well, why can't it be 135 degrees? Well, the reason for that is that that's in the second quadrant, so therefore sine inverse does not exist in the second quadrant, so it can't be then 135 either. So let's apply that same concept to this one. Arc sine exists only in quadrants 1 or 4. So go to your unit circle. What is the sine of 135? That's the square root of 2 over 2. So I'm asking you to give me an angle that has a sine of the square root of 2 over 2. So it's very similar to what we just did here. We're looking in quadrants 1 or 4. Again, it can't be 4 because that's where the sine values are negative. So it's got to be quadrant 1. And in quadrant 1, the only angle that has a positive square root of 2 over 2 is the sine, or the y value, is 45 degrees. So as I look at these two problems, what a lot of students will assume as I'm doing this problem, that the arc sine and the sines just cancel each other out, and that's how I got 45. Okay, if we make that assumption to be true, and I'm not saying that it is, if we make that assumption to be true, wouldn't that lead then for this problem that this answer should be 135? Well, it's not the case because 135 is in the second quadrant. So don't make the mistake that students have made in the past where they say, oh, arc sine and sine just cancel each other out. Arc sine and sine just cancel each other out and I'm left with that angle. Because that's not the case. And this is a great example to show you why it's not the case, because 135 degrees is in the second quadrant and my sine inverse doesn't exist there. Alright, taking a look at the next problem, I want you to find the cosecant of the arc sine of 2x. Well, we just actually did this a second ago, the arc sine of 2x. We asked ourselves where is sine positive and where is the sine inverse, where does that exist? Sine is positive in the first or second quadrants, and the sine inverse exists in 1 or 4. So therefore we've limited it to the first quadrant. And we already actually drew then our triangle. We're saying now draw a triangle that has a sine of 2x. So if I make that a fraction, it would be 2x and it would be 1. Now from this triangle, what I want you to do is find the cosecant then of the triangle. Well, cosecant, the formula for cosecant, since it's the opposite of or the reciprocal of the sine, is the hypotenuse over the opposite side. And so therefore, I don't have to find this third side here. It would just be 1 over 2x is my answer. And finally, if we look at this last problem here, the secant of the arc sine of x minus 1. So let's think about this. Where is the sine positive? And lastly, where is the sine inverse? Where does that exist? So the sine is positive in 1 or 4. Sorry, not 1 or 4. 1 or 2. And the sine inverse exists in 1 or 4. So we know this has to be a first quadrant triangle again. And let's draw one now that has a sine equal to x minus 1. I know sine is opposite over hypotenuse, so I'll make that be a fraction. And I want you to find now the secant. Secant is equal to the hypotenuse over the adjacent side. So hypotenuse would be 1, adjacent side is what I have to find. So if I'm going to find that, I'm going to have to use Pythagorean theorem. X minus 1 squared plus b squared equals 1 squared. And to actually use Pythagorean theorem here, I'm going to have to FOIL this. So that'd be x squared minus 1x minus another 1x would be minus 2x plus 1. And now what I want to do is move everything over to one side of the problem so that I can solve for b. So I'm going to subtract, add, subtract. So I end up, and I'm going to actually move up here where I have a little bit more room, I end up with b squared being equal to the 1's cancel out, negative x squared, and then plus 2x. And then to get rid of the squared, I take the square root. So b would be the square root of negative x squared plus 2x. So that would be this side of the triangle here. So that means then the adjacent side would be square root of negative x squared plus 2x. Alright, now I have to rationalize this. I can't leave that square root in the bottom, so I multiply both by that negative square root, or the square root of negative x squared plus 2x, square root of negative x squared plus 2x. Numerator is pretty easy. 1 times that is just the square root of negative x plus 2x. Denominator is pretty easy too. When you multiply two square roots by each other, the square roots just cancel out and you're left with what was underneath there. Negative x squared plus 2x. And so that would be my answer for the secant. Again, when you're doing these problems, it's very important that you take the time to ask yourself, where do my conditions exist? Okay, so where, in this case, where's the sine positive, where is the sine inverse exist? The other thing is to, once you figured out which quadrant it goes in, you're going to usually have to find the third side of the missing triangle, and you want to make sure that you give that the appropriate sign value, whether it's positive or negative. You know, and I didn't talk about that in this problem here, but I knew this had to be positive because it's a positive x value. If this was over here in the second or third quadrants, well then I would have assigned this as a negative square root here because this x value is negative in these two quadrants. And so that's typically where I see mistakes being made. You don't assign the appropriate positive or negative values with it. Never assign positive or negative values to the hypotenuse. Hypotenuse will always be positive.